Hi everyone, I'm Valentin. I'm going to deliver this presentation today about Oracle Converged database and how you can simplify application development with the Converged database Oracle provides. Not so long time ago, we were able to develop applications using just a single platform, one single environment on which we installed all the tools and the entire stack to create our applications. They were monolithic applications and everything was a lot more simpler than today, because today we are facing many challenges when starting developing new products, new projects. We have to include multiple workloads, multiple data types, multiple data formats. And this is not easy. So we need to make sure that we get the best value out of all this kind of data types we include in our development projects. For example, we would like to use machine learning to predict customer behavior and to find, for example, fraudulent transactions in our database automatically. We want to analyze communities to understand how we can promote our products and what kind of new services we can promote on these communities, on the social networks, for example, which are very popular today. And then we want to track our deliveries using spatial information, using location services. So this is very challenging, and we have to include all this information into new applications, into new development methodologies. These applications are using microservices, and they use, for example, the modules of the application in different components, which are deployed in containers, for example, as a microservice with an individual stack underneath. Then we have to process events and use messaging between applications. We have to be able to work with messages from our modules and from the development, starting with development. Another aspect is that we would like to provide API connections for our new applications to our customers to develop their own modules, or for our partners. A new methodology is using low-code frameworks. They're very popular today because you don't have to start from scratch. You can start with pre-built components and then combine them together to create the new applications or the new modules for your application. So if we want to combine all this in our new project from the development phase, we would have to use multiple data stores for the different types of data and for the different workloads. We have to use, for example, document store for JSON and XML. We have to use a spatial database, which is used for location purposes, a blockchain, a text data store, a specific database for reporting, specialized for analytics and machine learning, for example, and for graph, a totally different database. So this is going to be very complicated and very complex in the new project, and sometimes it is basically impossible to do it, because each one of the databases you see here, they have their specific requirements, and usually you can start with one single data store, but then the project, while it goes, it will require more workloads or different features to be added. And this is how you will end up adding those databases one by one if you don't have them in the beginning. So you will end up with multiple workloads, each one designed for a different specific single purpose data store, and with the data fragmented among multiple platforms. And also the people in the team will have to learn new skills for each one of the databases, and they will have to be able to manage those data stores, requiring complex solutions for the integration between the data stores, to replicate data, for example, the connections between the data stores, to replicate via database links. And it will require also the administration of the data stores. You will need specific tools for the database administration for each one of the data stores in the slide. So it's almost impossible. So how do you manage this kind of complexity? How do you and how do you simplify the architecture and start this application development without so much headache, like you have seen in the previous slides? The easier way is to use one single database for the entire development. This database has to support all the workloads, all the data types, and all the features you need for your new application. This is very easy to say, but not that easy to implement, because usually databases in general, they are specific to one single workload and to one single data type. So you will need a database which is multi-model, with the support for all the data types and data models you need in your new application, like JSON documents, XML, spatial location information, graph connections, edges and vertices, cube for analytics, free text for text search and indexing, blockchain for enhanced security. And then you will have to support all these workloads on top of that single database. The transactional workload, which is the usual workload for OLTP applications, but then analytics for data warehouse and machine learning, IoT streaming information and events maybe, and the database you can use in this case has to be also engineered to work in synergy with all these features. So they have to collaborate to produce a bigger result than their combined, than there's the sum of the individual features they provide. So the big question now is, are we going to go back to the monolithic application development like we used to do a few years ago, with one single platform for the entire application in one single monolithic deployment? No. The answer is no. We don't have to go back to monolithic deployments of one single database platform and one single stack for the entire application, because the Converged database also provides multi-tenancy. Multi-tenancy means that you can combine multiple containers in one single database installation, and you can use an individual container called Pluggable database in this case for each one of the workloads, and you can specifically tune and optimize that container for your application module. So how the Converged database will simplify the development methodologies, and let's go through each one of the methodologies to see how it works in reality. Um, the the development methodology has to simplify it, and it has to make it easy for the developers to create their application, giving them the entire support they need for the new application. But at the same time, if it's not very well implemented, you can complicate the data architecture, and then you will complicate the life of the administrators, the people which will have to maintain the application in the complete life cycle, during the full life cycle of the application. But with the specific features included in the Converged database, you can make sure that this the architecture is not complicated, and it will be easy to maintain and to administer during the full life cycle of the application. So the complexity can be eliminated completely if you implement it correctly. Let's see how we do it. We're using Oracle database and the Converged database capabilities we provide today with the latest Oracle database. So let's start with the microservices architecture. This is one development methodology which has been adopted in the last years to containerize the applications in different and their different modules in different containers, to encapsulate their functionalities in smaller installations, so they can be agile. You can change a container in a very short time immediately, and you can update the application with completely new features. Make it highly available. For example, you can fail individual containers and the application will still continue to run. And there are many advantages to containerize the application modules using microservices, for example. So Oracle database gives you the pluggable database and the multi-tenant architecture, which can help you to individually store the data of each one of the modules in their individual pluggable database. In each one of the containers I was explaining earlier in the previous slides. And this will give you isolation, and also it will give you the possibility to bring down or to move from one system to another system this pluggable databases, and to make sure that the application will stay online no matter what happens to each one of the individual stacks. And the second methodology is the event-driven architecture. Our modern applications should be able to capture events, process events, communicate events, and maybe the most popular platform, event processing platform, is Apache Kafka. So it is very important to be able to work with such platforms to be able to process events directly from the database. This is why Oracle has implemented this inside the database engine, so you can implement event streaming directly from Kafka and to and from Kafka. You can use Golden Gate, and you can use the database to query directly events from Kafka. So, and inside the database, we have the advanced queuing capabilities, features, which allow you to have database events inside the Oracle database. We supported this feature actually for decades with database queues and advanced queuing, providing full ACID transactions and powerful SQL queries over the events information. It is not something new, but this has been adopted maybe recently, and it has more importance now in a fully converged database architecture. The third aspect and the third methodology of developing modern applications is to provide API connectivity to your database platform. And this can be used in many ways. You can decouple, for example, the backend and the front end of the application, or you can provide your partners and customers the capability to communicate with your database and use your application programmatically using APIs. We provide in Oracle database Oracle REST data services, which is the very easy to use and available by default on Oracle Database Cloud Services, the REST API to communicate and to make REST calls like put, post, get, and delete to your database instance directly. So you can simplify and standardize the API communication, and you can extend it to microservices or to specific applications built by customers and partners that can communicate directly with the database. It's very easy to use and very simple. You can still manage the data with SQL, and if you enable the REST communication from the database, you will have both SQL and REST access to your data, no matter what kind of data you have, multimodal, as we have seen in the beginning. All data types are supported. Documents, spatial location information, graph, edges and vertices, analytic views and JSON documents and transactional processing data, relational data. And then for specific data types, you can also have specialized data access. For example, you can use property graph query language for graph. You can use XQuery for XML and simple Oracle document access for JSON, SODA. So you have multiple ways to communicate with the data inside your database. The next application development methodology is the low-code application creation using frameworks and pre-built components. You don't have to start your application development from scratch. You can use modules they are already created by other developers, where you can have packaged applications. You can move from one place to another using that framework, and they can run everywhere. Our platform for low-code application development is Oracle Application Express. And I believe everyone is familiar already with Oracle Application Express because it has a huge adoption among our users. And it is available by default on all database cloud services like Oracle REST data services, for example. It has deep integration with all the database features, and it supports, like other features we have seen, all data types you have inside the database, like documents, text, spatial, transactional data, and so on. Instead of requiring hours or days to create an application, you can create an application in just a few minutes with starting with, for example, from a simple spreadsheet, from an Excel spreadsheet, you can create an application. The next database development methodology is regarding distributed data architecture. You can have your database distributed among multiple locations across the globe in different cloud environments or even on-premise. This is very useful to have giant application, a very big application distributed across multiple sites to provide extreme scalability and be compliant with regulations you may have to across the globe. For example, if you have customers across EMEA, in Europe we have the GDPR, and all the information about European citizens has to be stored here locally in Europe, or you have to comply with certain regulations in order to store that information. Even if you're using the information from social networking and from any kind of identifiable information about European citizens, you have to comply with different regulations. So in order to comply with that, you can distribute your database in multiple individual database installations. And this can be performed with Oracle Sharding. Oracle Sharding gives you a data distributed architecture, and this allows you to deliver data sovereignty and massive scale using multiple single databases in cold shards in just one single database configuration, in a global database configuration. It is very convenient because all the functionality is built inside the Oracle database core database engine, and it uses replication and communication between those databases with global GDS, global data services, across those multiple databases, and they work like one single database, but the information is actually distributed in multiple databases across the globe. And they support also other database features like real application clusters, like Oracle multi-tenant. But in the end, each one of them is completely isolated and completely independent from the others. One of the last database development methodologies we are going to see today is the continuous delivery, continuous integration and continuous delivery. This is a new, well, it's not quite new, but it has been adopted lately a lot by multiple customers and the partners we have worked with. And they are deploying and delivering their modules in frequent updates, and they use one single code for the application development. They call master branch, and each one of the developers or each one of the teams will integrate their development branch with that master branch as often as possible, frequently. For example, even daily, we have adopters that are using daily integration with the master branch of their development progress. And this is very important because you can deploy easily and you can deliver new components for the application or updates for your application faster than before, using continuous integration, continuous delivery, without any downtime. So everything is going to be performed online in the integration, in the automated integration process of the branches and the workflows you have defined in the CI/CD server. And you will need support from the database to be able to make those changes automatically to the schema and to the data. And from Oracle database, from Oracle Converged database, we have the tools required to implement CI/CD at the database level, like edition-based redefinition, which allows you to have multiple editions, multiple versions of the application running at the same time on the same database. And you can choose when you want to switch to the final version, and once the end users will disconnect from their existing sessions and they will connect again they will be connected automatically to the last version of the application. We have online redefinition of the structure, like online table redefinition, which allows you to repartition, for example, a table, add columns, remove columns, and so on. And we have also native JSON and XML document support, which allows you to make schema changes at any time, because JSON and XML, they are schemaless. They are used for schemaless applications, and basically the structure, the information is defined in the same document, in the document itself. So they allow you to make changes maybe at every transaction. For example, you can have a customer which has a mobile phone and an address, and then you can have a customer which has a title and just the country and without an address and street and number fields. So you can make changes at any time. This continuous integration, continuous delivery methodology has been used by many big application providers like our partner Salesforce, but also internally by Oracle in the e-business suite and Fusion applications. We use the CI/CD methodology to be able to update applications immediately with no downtime and with minimal interruption to our end users' activity. To be able to provide change tracking and reporting, we are using one of our a tool which is developed by one of our partners. The tool is called Liquibase. It is an open source. It has a community edition, which is completely free to use. And they track, manage, and apply to other databases or other installations the schema changes from that master branch database you use for development. Liquibase can be called or can be used from multiple APIs or interfaces. Maybe the most popular is SQLcl, SQL command line interface we have with our database, which can run Liquibase commands directly in the same command line interface as the SQL commands. But you can use Liquibase from SQL+ or from the operating system or from SQL Developer, for example. If you are interested more about CI/CD capabilities, you can write me an email at the end, and I can give you more information, and I can give you some locations where you can start to learn more about Liquibase and the continuous integration, continuous delivery capabilities we have with Oracle database. It's very easy to generate change logs and with multiple change sets, and then apply those change logs to other databases in your development environment. Let's see now what kind of data types we support from the Oracle Converged database and how we manage to increase the value of your data with those new data types available today and which are very popular in the modern applications. We use the relational data to create analytic views and business data to be able to make predictions. We have machine learning, Oracle machine learning, which is available from Oracle database directly using the data mining engine. And we have more than 30 database database algorithms that can be executed for machine learning purposes. You can use also, apart from SQL, which is and PL SQL, which is the default interface to run data mining and machine learning, You can also use R and Python. They are easy to integrate with existing applications. Maybe you have created for machine learning purposes in R and Python, and you can call the machine learning algorithms directly from R and Python from your applications. This is now a feature which is available with for free with all database editions. It was included in advanced analytics until now, but now it is included. It is available with all database editions. For example, if you don't have any experience with the machine learning and you don't know where to start from, you can use AutoML. This is the easiest starting point for using machine learning with Oracle database. The AutoML is automatic machine learning, will immediately, based on the data and the predictions you want to make, it will immediately select and give you a list of algorithms that you can use with the based on the success factor you choose. For example, accuracy, if you by default is accuracy. Based on accuracy, it will give you the best algorithms you can use for your machine learning execution. It will automatically select the features from your data because maybe you have too many features and they are not all important for the execution. They are not useful for the predictions you want to make. And then it will also tune the model for you. So you will receive a tuned model which will be optimized for the best performance based on your database size and based on your resources. So it is easy to use. It is very easy to start with, and you can have machine learning predictions in maybe a couple of hours instead of days or weeks to study the algorithms and to create your own models manually. You can use directly the data you have in OLTP applications for analytics and even for machine learning, for example, purposes. Because we have what we call real-time analytics, basically is the capability of running analytics on the same OLTP data on the production environment by using in-memory columnar format and row format. If you want to increase the performance of the OLTP application, you can use in-memory in raw format. But if you want to increase and benefit from that server to use it for analytics, and you don't want to create a specific data warehouse for that, you can use the OLTP database and you can store the information you have in the OLTP database in memory in the columnar format, which is the easiest way for the analytics to be run, and they can run up to 100 times faster. In memory is an option, but it can be used up to 16 gigabytes for your on your database installation with no license requirements. It is included with Oracle Enterprise Edition, up to 16 gigabytes of in-memory area for your data. So you can use it to run analytics on the columnar format memory area of the same OLTP data without having to create a specific data warehouse environment for that. For graphs analytics, we can store graphs directly inside the database, and we can use traditional SQL or a specific language, which is PGQL, Property Graph Query Language, to query form patterns, to understand, for example, the relationship between persons in a social network, or between customers in our customer community, for example, to understand how they are influenced influencing one another, and maybe to discover influencers and try to work with them to give them special promotions, for example. The property graph feature, it is available in all database editions for free. It was a paid offering before. It required a specific license. It was the Oracle Spatial in Graph, but now it is included, and you don't have to pay any extra license to use the Oracle Graph in Oracle database. If you want to use your Oracle database as a document store for storing unstructured, or let's say schemaless documents like JSON and XML, you can use directly the same database you use for OLTP applications. You can have a mix of traditional relational data and JSON documents in the same database, and it doesn't affect the database performance or the configuration of the database at all. It is completely transparent for the applications, and you can query the JSON data via traditional SQL, even using parallel SQL for analytics to run and query multiple JSON documents at the same time to access huge amounts of information for your business queries, business analytics queries. Or you can create joins across documents, and it is the same as managing the traditional relational information, the traditional relational data inside the database. You can create views, materialized views, and so on top of JSON documents. But you can also use SODA, Simple Oracle Document Access, to access your JSON documents from your most popular programming languages like Java, Python, PL/SQL. So we are supporting multiple languages to be able to access documents using SODA, Simple Oracle Document Access. You can store free text information in the database. For example, you can use your database to store customer reviews for your products inside the database, and then you can use indexing on those reviews, or you can store files like documents, PDFs, and do a search on those files. On top of those files, we support many types of search, like based on a pattern, based on a keyword, or even fuzzy search. For example, looking for a word that sounds like a specific word. There are multiple options to search documents and to create your indexes on top of the documents. You can also run a linguistic analysis or semantic analysis on top of the information you store as free text inside your database. For example, you can analyze the contents of the customer reviews to classify them into positive, neutral, or negative using sentiment analysis, using the machine learning algorithms we have in AutoML, in Oracle Machine Learning. You can even have those documents stored as schemaless documents, like semi-structured information, JSON and XML. And you can use the document search to find keywords or to find patterns in those JSON and XML documents you have in Oracle Text, using Oracle Text. Spatial data is also very important. We are using more and more location capabilities on our smartphones, on our tablets, on our devices. Now we have Internet of Things. Everything is connected. Cars, trucks, deliveries are always tracked via GPS. And you can store that information, and you can use Oracle Spatial to analyze the information, the spatial information you have inside the database. We have over 60 spatial topology functions and procedures, and more than 125 spatial network functions and procedures. And this is also available for free with the database. It was an option before. I'm mentioning this because maybe if you use this before in Oracle 11G or even Oracle 12C, you know that you are supposed to pay an extra license for these features. But now Oracle Spatial is available by default. Oracle Machine Learning, or it used to be called Oracle Advanced Analytics. It is also completely available with the database without any extra license, and Oracle Spatial is the same. If you want to increase the security for the applications and make sure that nobody will be tampering with the data inside your database, you can chain the transactions or the rows inside your tables in a cryptographically chain, and this will make your tables immutable, and they will have an extra column, which is the blockchain hash value, which is computed based on the previous hash plus the contents of the new row. And this will make your data basically completely secure. Nobody will be able to change the data in your records, because it will break the cryptographical chain of the records, and this will be immediately identified by your database administrators or your application administrators. So as I was saying, all new inserted rows are cryptographically chained using the hash value of the previous row, and in case someone wants to change anything in the row, it will break the cryptographic chain and it will be identified immediately. So this is like a ledger basically, and it supports full analytics and transactions on the same blockchain data. So you can use it for both analytics and also for OLTP applications. For Internet of Things, we have fast ingest. Fast ingest is a new feature of the mem-optimized set of features as mem-optimized for write. In this case, you can insert huge amounts of data inside the database in a very short amount of time by bypassing the traditional transaction engine of the database. You don't have to commit. Those transactions are not committed actually, and they are written directly to the database in deferred asynchronous writes from the memory. So the information is received in a specific area in the memory, in the in-memory ingest buffer, and this buffer is written in deferred transactions to the storage directly without committing the data and bypassing the transaction engine of the Oracle database. We managed to achieve up to 25 million inserts per second on a simple 2-socket server. And it is very useful for IoT devices which are generating huge amounts of information in a very short amount of time, like temperature sensors or testing facilities. So all this information we have seen and all these data types are the components, the main components of the Converged database capabilities, and they are not just for transaction purposes for OLTP applications. They can work also for analytics, for data warehouse environments. And I mentioned in one of the few slides that some features are mostly for analytics, or some features are mostly for OLTP, but you can use them in both flavors, in both optimized configurations for OLTP databases or for data warehouse configurations. And you can use the data warehouse, for example, to increase the capabilities of the analytic engines, to be able to insert data and extract data in real time without with a huge performance, to run analytics automatically directly on the business data, maybe on OLTP production environment, and you can use it with the autonomous database, with the autonomous data warehouse we have as a service on Oracle Cloud Infrastructure. So it is available in any kind of installation and for multiple purposes. You can deploy actually the Oracle Converged database everywhere. Both the OLTP, the database, or the data warehouse database. You can have it in the cloud, in Oracle Public Cloud, OCI, in multiple configurations, in multiple flavors, shapes, and even in autonomous configurations, specific for different workloads like autonomous transaction processing, autonomous JSON database, and autonomous data warehouse. You can have it, the Converged database, on third-party clouds, on virtualized environments, on-premise, and we support any kind of commodity hardware for Oracle database. But you can also have it in specialized installations, optimized installations, and maybe the most powerful configurations with Oracle engineered systems. We have engineered systems you can have on-premise, but also engineered systems you can have on the cloud, like Exadata Cloud Service or Cloud at Customer environments. They are the same engineered systems we have in our data centers, but you can deploy them in your own data center behind your firewall, and they can work like Oracle Cloud Service, but in your own environment, closer to your applications, and having full control of the data and the location of the data, because it is actually inside your business. I'm going to give you, in the end, I would like to give you an example of what can we do with the Oracle Converged database. And actually, this is an example we have created on an always free cloud account. This is a completely free OCI tenancy you can receive. When you subscribe for a trial account, you will have up to $300 to spend during 1 month. But then once you consume those credits, or if the 30 days period is complete, you will receive access to an Oracle always free tenancy, which is limited to just a few services, like including the autonomous database. You can have up to 2 autonomous database instances deployed on an always free environment, and you can have some compute nodes, some Oracle storage, Oracle Cloud Storage, block storage, and buckets, for example, to start your first development projects on Oracle Cloud. And in this case, the example uses low-code development with database actions and application express, and the communication is done via Oracle REST data services with REST calls. So I had this conversation with some of my friends. They are professional developers developing mostly mobile applications today, because this is the future of the development. One of the trendy development ways of creating new applications, which are running also on mobile devices, or at least have a couple of components which are running on mobile devices. And they were asking if the Oracle Converged database can be used to create mobile applications or components for a huge application, but running on mobile devices. And I said, yes, of course, you can use Oracle Converged database. And we started to check this, the capabilities and how you can have mobile applications communicating with Oracle database directly in the cloud. And we tested the REST communication, so you don't have to create database adapters into the application. You don't have to manage connections and very complex transactions. You don't have to manually code all the data transfers because it is handled by the REST calls via HTTP verbs. The data doesn't have to be in a specific format or type because we can use JSON to make the communication work between any kind of application, including the mobile application in this example, to the database server, and everything is secure by default because Oracle REST Data Services (ORDS) has SSL certificates implementation on Oracle Cloud, including the autonomous database deployments. And then the communication is done via HTTPS protocol using transport layer security TLS. And the authentication, it is offered by the OAuth client credentials you have to use to create a token and use the token to maintain the session with your database server. And once the token expires, you have to create a new one. So it is very convenient and very, very easy to use. If you want to find more about this simple example about how to develop new applications using new methodologies, using the Oracle Converged database, you can visit the dbnotify.oraclexp.com webpage. And there I'm explaining in more detail how to create this kind of example. And soon we will have a workshop showing developers how to create and how to develop applications within these new methodologies. And even I'm going to give you more details about this example. So this is the summary of the presentation we have seen today. We are close to the top of the hour here. So Oracle makes it very easy to build data-driven applications by providing synergistic data technologies from the database platform itself. You don't have to deploy multiple components, multiple software products to get all these technologies. The Converged database, it can be used for any kind of data models and data types, as you have seen in my slides. And it simplifies the development. This is the main goal. Maybe the third point on the summary is maybe the most important. Because we care about developers. We would like to make developers' life easy and make them happy. So we would like to, we are going to simplify their work with Oracle Converged database. Once you adopt the Oracle Converged database, you will understand that it's a lot easier to use this database than any other data stores specialized for the single purpose workloads or for single purpose data types. So this is the main objective we have with Oracle Converged database. We also have live labs. You can use live labs to understand more about Oracle database in general. There are multiple online workshops you can run by yourself on our live labs platform. Just go to bit.ly/go live labs, and there you'll find a huge amount of hands-on labs you can run by yourself to understand more about all database capabilities. And now I have 5 minutes for Q&A. Please send me your questions via chat, or I don't know if you can unmute yourself to ask your questions. I'll be happy to answer any questions you may have.
Thank you so much, Valentin. I don't think that the attendees can unmute themselves, but I can do it. So if anyone wants to ask the question, just raise his hand and I'm unmuting him. Or if he prefers to write it, write it. We have a couple of minutes for answering question. I'm not seeing any raised hand. And I'm not seeing anything in chat. So,
do you have any questions, Mirela, about the Oracle Converged database?
Well, yes, but I think it will be a longer discussion, so I will keep the discussion offline.
Okay. So
yeah, when I've seen the Oracle text, I was suddenly very interested in that part of discussion.
Sure.
And okay, about the continuous integration and delivery, I understood that you have an agreement with Liquibase. That's why you are using Liquibase, or you compared with Flyaway and you think that it's better to use Liquibase?
Liquibase has the community version, which is completely free and can be used directly from SQLcl. So we integrated, we have this agreement to integrate the community version of the Liquibase in our interfaces in SQLcl. But then Liquibase, they have multiple products, enterprise level products with licenses, and they have more features. For example, if you would like to run change tracking and management from a graphical user interface, they have a tool with a GUI for managing the change sets and the change logs directly from a graphical user interface with many features, user-friendly, with drag and drop. You can set up the priorities and the order of the changes. I've seen some demos, and I tried those enterprise features. They're really nice, very useful. However, as a starting point, you can start with the community edition with the SQLcl command line interface, and it is very easy to use. We have also some hands-on workshops if you are interested about Liquibase and Oracle database, how to track changes and how to include those changes in a CI/CD workflow with multiple pipelines, and how to store them, for example, in your repository, maybe on GitHub or whatever repository you may have for your application development.